a little bit of definition stuff. So when we multiply any number by 1, we get the same result, don't we? And so 1 is referred to as the multiplicative identity. In other words, the number that you multiply the original number by to get the same answer. 3 times 1 is 3. All right. Matrices also have a multiplicative identity. However, we can only work out that identity if our matrix is square. By square, I mean it's a 2 by 2, 3 by 3, 4 by 4. Now, for us, you'll be pleased to know we only really ever work with 2 by 2, occasionally 3 by 3. But if we have a 3 by 3, we'll often use a calculator. So, the multiplicative identity for a 2 by 2 matrix is 1001. All right, that's what we call it, the 1001 matrix, and we give it the symbol I. For my 3 by 3 matrix, you can see that the diagonal of 1s, all right, and the rest of them are 0. So what that means is, if I multiply any matrix, 1, 2, 3, 4, times 1001, I get what I get. I get 1 times 1 plus 2 times 0, which is 1. 1 times 0 plus 2 times 1, which is 2. Go to the new row. 3 times 1 plus 4 times 0 is 3. And then 4 times 0 plus 4 times 1 is 4. So we get the same matrix back. That's what my identity matrix gives me, all right? Now, that sort of becomes important. We want to try and solve some equations, all right? So, well, we should nearly know what these answers are. If A is equal to 2, 3, 1, 4, find AI. So, given what we've just discussed, two by 1 plus 3 times 0 is 2. 2 by 0 plus 2 plus 3 by 1 is 3. New row, 1 times 1 plus 4 times 0 is 1. And then 1 times 0 plus 4 times 1 is 4. So that's what I get for AI. If I do IA, that means I have 1001 times 2314. What's that going to give me? 1 times 2 plus 0 times 1, which is 2. And then I get 1 times 3 plus 0 times 4, which is 3. 0 times 2 plus 1 times 1, which is 1. 0 times 3 plus 1 times 4, which is 4. So both of them give me, so it doesn't matter whether I, what we say, pre-multiply or post-multiply by the identity. So this is pre-multiplying, and this is post. If we multiply any matrix by the identity, we get the original matrix. All right, that's important. So what we want to do now is talk about inverses. All right, and we've spoken a little bit about inverses in our functions. What we want to do now is the inverse when it comes to matrices. Okay, so it's the inverse of a function, or the inverse of 3 is the number that we have to multiply 3 by that gives us 1. So it gives us the it just gives us 1. All right. So in other words, 3 times 1 on 3 is equal to 1. All right. Now, if we have a 2 by 2 matrix, we want another matrix B, so that it doesn't matter whether we multiply by B at the start or multiplied by B at the end, I'll end up with the identity matrix. All right, so that's what the inverse is. All right, now this inverse matrix has a particular property. So if A is equal to the matrix A, B, C, D, then the inverse, A inverse, is given by what we call 1 over the determinant. And what happens here? We swap A and D, so we swap our diagonals, and we change the sign on the other diagonals. All right. So that's what happens to the matrix. This determinant, okay, is given to us as, if that's my matrix, A, B, C, D, the determinant of A is multiply these two together and then subtract the product of the other two diagonal together. All right. And important to note, if the determinant of A is 0, then the inverse doesn't exist. So let's just work through that slowly. All right. Find the determinant of A first. So the determinant of A is equal to 2 times 5 minus 3 times 3, which is 10 minus 3, which is equal to 1. All right. Which means then the inverse of the matrix is given as 1 over the determinant, which is 1. And what happens to the matrix? We swap over A and B. So I swap those two values, so it becomes now 5 and 2. And the other two corners, I change the sign. All right. So if I simplify that, 1 over 1 is just 1. And we get 5, negative 3, negative 3, 2. That's the inverse matrix. All right. So what that means now, the property that that has is if I decide to do A inverse times A, I'm going to have 5, negative 3, negative 3, 2 times the A matrix, which is 2, 3, 3, 5. What does that equal? I get 5 times 2 plus negative 3 times 3, which is 1. 5 times 3 minus 3 times 5, which is 0. Negative 3 times 2 plus 2 times 3, which is 0. And then I get negative 3 times 3, which is negative 9, plus 2 times 5, which is 10. Okay, and it doesn't matter if I do the opposite order. And if I do A times A inverse, I'll also get the identity matrix. Okay, which is almost the same as getting 1. All right, so that's why we find the inverse, because the inverse now gives me a way in which I can multiply two matrices together and get 1. All right, so go into 7F and have a practice with that.